Thanks everybody for coming in. My name is Nikita Ivanov. I'm a CTO of a company called GridGain Systems. I'm also a technology advisor to a company called DataLingvo, technology of which I'm going to be talking today. And I want to talk today about basically two things: cognitive analytics, why and how, why is it important, and what DataLingvo did specifically to actually implement that technology. It's pretty cool stuff. And we'll talk about Human Curated Linguistics as the technology behind that. So let me talk about a little bit about the reason why we talk about cognitive analytics. And I don't want to give you the entire business spiel on this, but it's kind of an interesting aspect. A couple of years ago, I've seen that Gartner basically made a very interesting statement. I think it applies to all of you guys. That the only people today that have effective access to the data in any organizations are the people that don't have any questions of their own. Think about it. It's a data scientist, data analyst, anybody else. People who have no questions of their own. They only exist in an organization to find answers to other people's questions. Now think about it for a second. It's a very profound statement. That's how we basically developed the entire BI and data analytics systems for the last 35 years. We developed them for a very small group of people in an organization that typically have no questions of their own. And people that do have questions literally have no tools and no ability to access the data. So what also happened in the last maybe 5 to 7 years is the huge growth in SaaS applications. If anybody remember 15, 20 years ago, all of our business data was in SAP, in Oracle, or PeopleSoft, systems like this. Today, literally every company, small startup to mid-sized company, would have at least half a dozen different SaaS systems where we keep our business data. Salesforce for CRM, Google Analytics for web, AdWords platform, Google Merchant platform, Twitter, Facebook, LinkedIn for AdWords, Workday for HR, Benefits, QuickBooks for finance, Jira, Asana for project management. List goes on and on. Any company today would have literally half a dozen different SaaS systems that are completely incompatible. I will challenge anybody who can find me one person who knows both Salesforce and Marketo, for example. They don't exist, although there's two major systems that's used constantly in every business. Replace Marketo with HubSpot, problem becomes even more complex. On and on and on. So basically what happened today is the corporate business data is really trapped in silos. And those are true silos. They're incompatible, the data model is incompatible, query language is incompatible. Like in Salesforce, you have to know SQL to query it. In Google Analytics, you have to understand data warehousing. It has dimensions and metrics. So basically, people don't really have access to it today, except for the few, and those that do, process is fairly complex and costly. This is basically what's happening today. Business users, I believe of data scientists, typically, I recently spoke to a larger bank here in the Valley. The larger bank, multi-billion-dollar organization, they have about 12 data scientists for an entire bank. That's what those 12 people have all the tools necessary to actually access the data, and they have thousands upon thousands of people that basically have to go to those 12 to really, ask any type of questions. So you go through this, they do some programming or some data science, and a couple of days later got you answer. What's also interesting, and if you talk to any analyst, they will tell you that absolute majority of the business questions are not life and death issues that require your immediate attention. It's typically, simple questions that people have hunches during the meetings with, their teams, the customers. Most of the questions don't warrant, going to some special department, asking to produce some report, wait for a couple of days and get your answer. Most of the questions we have are ad hoc and exploratory. We want to basically see, we're on a customer meeting, we're meeting with our sales team. What happened? We just launched our AdWords campaign in New York. Did we have any, pull up on the website in the last couple of weeks? Typically questions like these don't get answered immediately because literally if you don't have it like a dashboard to build already, you cannot really answer that. So cognitive analytics is the upcoming term that basically defines a product or a process by which anybody in an organization can ask any questions about business data just by using natural language. The basic way to think about it as a Siri for BI and data analytics. 10 years ago, we didn't have Siri or Cortana, Google Now, any of these technologies. We had to type and navigate all complex interfaces. Today, we can simply talk or type most of the time and ask our questions and really get answered. I always bring this, important compatible. Look back in the early 90s. Search of a network was an engineering problem. Think about it. who would write in right mind will be searching for some document on a local network? All engineers would do, right? It was an engineering task. Fast forward 15, 20 years back, and forward, I mean, anybody, kindergarten and his grandparents can search the entire globe of information just by typing a few words in Google. Exactly the same transition will be happening with the BI and data analytics as we speak. This is, by the way, this is a screenshot. By the way, in the end of it, I'm going to show you a live demo of the system. It's pretty cool, by the way. But this is a live shot of what DataLingvo looks like if you really want to ask questions about a data in your business. This is as simple as this. It's actually very Google-esque, if you ask me. There's literally a text field in the button. There's nothing else you need to do. That's a fascinating difference between everything you guys know. Look at every data science platform, or any data analytics platform, any BI platform for that matter. It always have much more complicated interface with complex UI and everything else. Here you can literally talk or you can type and basically ask practically any question today and get a real-time answer. And we'll talk about what's behind that. By the way, this is the type of results you're getting. So very simple interface in the back end, on the front end to ask the question. But once you get the answers can be fairly sophisticated. You get information back by just asking simple questions using natural language. It's the type of questions you can ask. Think about this. You can actually ask something very generic, like some of the top 10 most active cities for the last 90 days. And if you connect it to Google Analytics, you'll get the answer. Now take a look at this. I don't really know what active means, right? I don't really specify what active means. All I basically know that I have a website and there's notion of activity in the website, and every system will treat it differently. For example, Google Analytics has sessions and new users and other entities in it. But all I have to do is to ask this very generic question to get the exact answer back. I don't need to know what specific data model is behind Google Analytics. We also support Salesforce in some limited form. Look at this question, for example, over here. What is the correlation between new users and opportunities created for each state? It's a pretty cool question. Just imagine how much it will take you today to answer the same question. So the question is, do you have any correlation between new users and the new opportunities that we just created in Salesforce? Maybe people come to our website and they're buying something right away. Very benign question. Today, I challenge anybody to produce a result in less than a couple of hours. You have to go to Google Analytics, create a report, massage it, export to a spreadsheet. Have to go to Salesforce. If you have a report lock, if you don't, program in SQL, get the report, export to a spreadsheet, normalize dates formatting, and join them together, then you get your result back. And that's, you have to basically know two systems. It's a multi-hour process if you have two people working on it. And how easy to get these two people working in an organization. In a system like DataLingvo, that takes just a few seconds. Literally, just ask this question, and we'll get back the response. Some of the questions can be fairly complex. We're not talking about simple ones. You can actually ask a very detailed question, and you'll get the response back. Like this, for example. You can ask, give me all the data by states where essentially user numbers increased 20% month over month for the last 2 months. It's a pretty sophisticated question. Again, to answer this question, Google Analytics doesn't support these type of questions at all, by the way. You have to run 2 reports for multiple months and manually in a spreadsheet join them. Here, since we have a complex SQL post-processing, and we will understand. Now, this is like kind of important. I present a lot about this technology lately, and there is a fascinating properties about the natural language when it's applied to BI and data analytics. First of all, it provides radical simplification. That's pretty obvious, right? What can be more simple than something you and I already know? Think about this. Natural language is the only one interface between you and the data that you don't have to learn. You already know it. If you can speak, at least in English, you already know it. It's very fascinating properties. Zero learning curve, zero barrier to adoption. Think about this. You hire a new person in your company. She walks in the office, first time, first step, first minute, she can already make data-driven decision because she already knows how to extract data, how to ask questions. It's a very disruptive ability in this way. It enables millions of people, literally. The BI is not new, and data analytics is not new. What it does, it opens up an existing business process to an entirely new class of users. All of a sudden, not only those 12 data scientists can actually access the data, anybody in your organization with the proper permissions and security, can answer practically any data. It's a very interesting ability. What's also interesting is this. It is ideal interface for all our new upcoming devices, for mobile, embedded, and wearable. If any of you bought an Apple Watch, there's no keyboard on it, right? There's no keyboard on most of our devices going forward. We're going to be talking to them, at least typing, at least accepting the text input. If systems not designed today with acceptance of the speech or text as the input, they'll be pretty much outdated pretty soon. Look at our GPS in the car. Half of them already support speech input. So we're going to begin going in this direction. Look at the Cortana from Microsoft. Look at Google now, how they move in enterprise space. Look at Amazon. It's literally getting there pretty quickly. So the speech and the input will be pretty much the key one. But this is probably what's most interesting. The natural language is the only common uniform interface to all data sources. Think about this. What's common between Salesforce, HubSpot, and a Workday? The answer is nothing. There's nothing in common. Different data models, different interfaces, different accounts, different approaches, different everything. The only commonality between them is that you can express your question in a normal language. And if you can, and the system understands, that's the only commonality there. I can ask questions, what's my total revenue for the last year on the East Coast? That's a good question. I can ask, what's my average benefit cost for the last quarter? That's a good question for Workday. And I can ask HubSpot, what's my top funnel numbers for my leads, right? I can ask those questions, and I have no idea how to use any of those systems. But I can ask those questions, and if the system will understand me, that will be a breakthrough, because I could use all of this data for my own needs. So by now you're probably asking, how the hell you guys do this? Because it sounds pretty fantastic. So that's why actually I want to stop here for 10-15 minutes to really kind of give you the rundown of how do we arrive to the system we have today. So the project started about 2 years ago, and originally, as almost anybody else in NLP phase, we decided to go through a kind of break, through computational approach, computational linguistic approach. Obviously, if you know anything about NLP, pragmas and languages don't compute. You can compute, a strict grammar sentences pretty quickly. The minute you have a context, which is pragmas in the language, that basically provide you this semantical context, they don't compute. It's impossible to compute them properly or translate them into some kind of intermediate language. So we hit the wall pretty quickly, and then we kind of swung all the way different directions, saying, okay, we're going to use the deep learning stuff, neural networks. The problem with the whole deep learning situation is that what many folks don't realize, it's not an exact thing. It only can give you a probabilistic answer. It has built-in imprecision. So it's acceptable for a lot of use cases. So for example, if you do Twitter sentiment or any kind of sentiment analysis or computerized vision or categorization, imprecision is allowed. It doesn't really matter if your Twitter feed is 65 or 66% positive, right? It only matters that it goes in the right direction and kind of in relation to the group values. But if I'm asking you what my revenue for the last quarter, I need an answer to the penny. That's why, for example, IBM Watson cannot be used in any of the BEA systems like this. Because IBM Watson is a deep learning system, it can give you, what, your revenue for the last quarter was about, $2 million with a 95% probability. What do I use with it? What do I do with this information? What's very interesting that for the BI and data analytics, for some of them, especially for the corporate business data, imprecision is not allowed. So essentially, what we were faced a couple of years ago is that we cannot use any of the existing tooling or technologies at all. Computational breakthrough, kind of work doesn't work. Deep learning doesn't really work as well. So we started searching basically, and we came up, pretty interesting study how our brain works and how we analyze the sentences. Let me give you an example. Imagine I ask you a question. Again, back to our web analytics example. What are the top 10 most active pages on my website? Imagine how many different ways we, the humans, can ask this question between ourselves. Can you show me what are, can you list me, can you display to me, can you email me, most active, most visited, most viewed, most touched pages, web pages, HTML pages, website pages for the last whatever, weeks, months, days from this date to this date. So permutation really go in tens of thousands of permutations. Although it's exactly the same question. And our brain is wired in such a way that we never spend a second trying to compute all this. We immediately see the core semantical patterns in this question. So for example, we immediately understand that this question is about active pages for this data range, period. If we say top 10, we know it just to give us a top 10 only. So we immediately, narrow down to the key semantical components of a question, immediately describing all the stop words or stop sentences or stop sentences. That was pretty interesting, and we decided, can we build the same algorithm? And we did. So essentially what we've done, we've developed a process by which we take any sentence that you basically either say to the system or enter through typing, and we reduce that sentence to a theoretically minimal set of semantical DNAs. Typically, reduction goes by order of 3, sometimes by order of 4. Once we have that sequence of semantical DNAs, as we call them, now here's the key process here. We look at our system and see, have we seen that sequence already? If we've seen it before, that means we already have an answer for it, we have a query for it, so we basically do automatic substitution and return result back to the user. If we haven't seen that sequence before, we try to come up with the automatic answer for it, but this is the key. We give it to the human being to double check it or correct it. Now think about this. The human correction is not new. Quite a few companies using it. But that process gives us 2 unique properties. First, we never introduced error into the system, because there's not a single question in a system that has been automatically answered without a human interaction. Each question at a certain point of time was automatically answered, but checked by a human analyst and corrected as well. Second of all, not only about the correctness, it gives ability to process a completely free-form, unrestricted language. We're the first systems, as far as I know, in the world today, that you can make grammar mistakes, you can misspell things, you don't have to follow any specific grammar rules. Obviously, if we can understand it all, some kind of gibberish, we will not answer this question. But you don't have to spell things properly, you don't have to follow a grammar, you can use the same language that you and I speak. Think about this, on a Skype instant messaging, none of you follow an exact grammar. We don't do this as humans, right? We just type the way we like and using some lingo, using some shortcuts in the grammar. As long as we as humans can understand what's going on, that's how we interact, right? If you look back in the history of NLP systems, and we did a pretty extensive study there, most of the NLP systems with this kind of question and ask ability failed, because they were asking people to follow an exact grammar, an exact set of words. But if you follow in this, people basically don't like it, because I might as well just learn a particular interface than just follow an exact words, an exact grammar that I need to follow for it to be convertible to, let's say, SQL. This is the first system, because of this human interaction in a loop, where you can ask pretty much any type of question with any type of limitations or shortcuts in grammar or misspelling or even contextual confusion, if you will, and it will be possibly understood by the system. Now, I get immediately the questions, well, if you use a human for each question, wouldn't this scale as a business or technology? It will. First of all, this loop is real time. In real time, it takes to involve a human to double check a question, takes about 5 to 10 seconds. And that's the know-how of this company that they build it in. It doesn't take overnight, it doesn't take an hour, it doesn't take a minute. Typically, it takes just a few seconds for a human being to double check or make a correction to the answer. So from a user perspective, they don't see a difference. They basically see a question being answered right away with pretty full answers. What we also do over here, once the question is being answered in real time, in offline mode, we have a pretty deep supervised learning algorithm. And let me just give you a couple of ideas of what we do essentially there. Imagine that we have answered on the 2 small questions. We have this, 2 DNAs sequences, 2 sequences of DNAs already answered, and we know they're correct. We can take those 2 sequences. For example, we can take one sequence from Google Analytics and one sequence from Salesforce and learn how to answer more complex questions in a fully automated way. And we can do that because we know that each part is correct. We don't introduce any errors in that algorithm. It's pretty advanced stuff. What it really boils down to is that the system has tremendous self-learning capabilities. With every question that hits the human being, we're not only learning how to answer the all permutation of that question, which can be in tens of thousands of permutations of the same question, we're also learning how to answer more and more combined questions from those small tokens we actually just answered that. So the company is pretty early right now, but the models show that it has at least exponential growth in terms of the self-learning capability. Essentially, with every question that human being answers, more and more questions, up to sometimes thousands more, automatically now being answered in the system. So what's really cool is that the calculations show that probably within 9 to 12 months, system can saturate its knowledge about any particular data source, which means essentially after about a year of work, it doesn't need to have humans. All the questions already been answered and correctly in the system. And that's a very unique property of that design, that we don't have to keep the human beings on data source forever. They can be now redeployed to new data source and so on. Yes? Yeah, this is the snapshot of the interface that basically exists in the backend. It looks pretty sophisticated, but most of the time humans just have to look at what was the question and what actually is performed as automatic analysis, and literally most of the time just say yes or no. If the question is automatically answered and it's incorrect, then basically it goes and fixes something. That's where you can spend those 15, 20 seconds, that's for sure. Because if you're just looking at it and say yes, no, it's a 2-second decision, right there, boom, boom. If you need to correct it or extend it, then yes, it can take up to half a minute. Still, it's a fairly fast interface, because half a minute versus hours it takes today is a huge progress. So this is actually, I think it's my last slide, I think, and maybe a couple more. But this is basically a snapshot of what we see on the back end of the system. So back end is fairly complicated, a lot of science there, pretty deep stuff. That's the interface that data analysts from the back end sees in real time. So just a few words about a whole system design. This is kind of less interesting, this is more interesting. We're fully in-memory system. We're based entirely on memory architecture for its speed. We use Apache Ignite. This is actually the company and the project that I started many years ago. It's a fully in-memory system, so we run entirely in memory on a pretty large cluster of computers. We use basic Stanford NLP and WordNet for all the basic NLP, mechanics. We obviously don't do any part of speech or lemma or stemma. We just borrow it from NLP, from Stanford NLP. We developed a lot on top of that. We have very complex, for example, there was a couple of questions about stop words in the previous presentation. We have fairly complex dynamic stop word mechanisms. Well, obviously, we don't do stop words. Nobody does stop words. Everybody does stop sentences. Stop words, like 5 of them. So stop sentences, actually, we dynamically create them based on data source, and we've been pretty smart about it. In this way, we can actually deduce stop sentences very effectively, not just by words. And we have, fairly sophisticated analysis based on Stanford NLP. So we Scala backend entirely. We love Scala. On the front end, you're going to see the demo. The front end basically very typical. It's AngularJS, Node.js, and the rest of the stuff. We use Cordova for all the mobile clients, and we use Postgres and head of the storage. Pretty cool stack on the market automation, but I'm not going to spend too much time here. So I think this is the last slide, and let me actually show you some demo stuff. Because it's kind of cool to look at it. I think I have plenty of time, about 10 minutes, okay. So I want to make sure you guys see it perfectly. So this is actually a live system. It's not a demo. It's a live system where it's company's in private beta right now. If you want to sign up, just go ahead and sign up. You can basically get access to it if you like. So let me go ahead and sign in over here. I don't remember my password properly. All right. So this is a very simple interface, by the way. The simplicity of this interface is on purpose. The company pays a lot of attention to the UX and UI type of things here. Keep in mind, this is going to be used not by data scientists. It's going to be used by average rank and file business users. And that's why interface is very clean, very simple, very not threatening. And we're trying to keep it this way. So, interface is pretty simple. On top we have a typical toolbar. The interesting part is here, basically, it's your inbox where your questions come in. and all the questions that you're waiting for example, or you answered before, they're here. You can look at it. So let's go ahead and ask. Remember the question we've basically been talking about, like in the top 10 cities, right? We can go ahead and ask this question. One thing you notice immediately that the text box here is pretty smart. It has a lot of models built in, so it predicts what you're trying to ask, so you don't have to type a lot of things. The very important thing is that, for example, for geographies, everybody misspells names of cities and countries and states. Like Mississippi, for me, not American born, I'll misspell it every time. So for these things, we have, pretty cool autocomplete. So for example, if you want to ask for like Moscow, it has a Moscow. If you want to know how San Francisco is spelled, you can find a lot of San something else. But let's go ahead and ask the question about top 10 most active city. So we can say, the top 10 most active cities for the California, and we can pick this one for the last 3 months, for example, something like this. And that's it. Just go ahead and enter it. And what you're going to get back is a pretty nice looking and pretty simple result set that has a lot of information in it. Hopefully you guys can see it on the screen. So on top of it, you have a lot of stickiness, and we'll call the kind of habit creating tools, features, if you will. You can give us a feedback. You can see which data source it came from. But then you can see basically your question in a little bit different shape and form. We're actually showing you how we understood what's happening here. So show me was detected as a stop word. By the way, this is pretty cool. If you just detect stop words as a words, you will never mark show as a stop word. It's a verb. It's a very strong verb. You will never actually, you will never get it as a stop word. But if you do it a little bit more smartly, you can basically detect that this show me literally a stop sentence here. And we do pretty good analysis there. So we actually basically showing you that the top 10 is the result set limit. The cities actually is the Google Analytics entity, because we know we're talking about Google Analytics over there. The California here will be geography location, and the last 3 months is just data range. So you can do a lot of different things. You can export it, you can share it, you can customize this whole data, many ways as you like it. You can basically show these things over there if you like, just to make sure we can show them. And page and view, and basically everything else is pretty obvious here. We have the charting that's actually here as well, and you can play with this chart as much as you like. A little bit different formatting here. Since you already have the geography information in this question, we're also showing you the mapping view of the same data that you basically got. Now, pretty cool, right? Take a look at this. We just asked this question, right? It's a very simple question. And by the way, typically this question can be in the dashboard for Google Analytics, so it's not really interesting. We'll look at something more interesting. But you get a fairly interesting result back, fairly workable and it's fairly knowledgeable, and it's easy to consume what it's in there. Now, if you go back, remember I told you that basically if you ask the question in one shape or form, you can now basically change a lot of these properties without ever going to a human being, right? So we can change a lot on these questions. So for example, we can change, say 20. We can say, show me please, active cities for, let's say not city, let's pick one, let's say that's Nevada. Probably going to be just a couple of cities there, right? And we can say, let's say for the 2 quarters. So we change the question somewhat, added words. And again, we can just click, and it will be automatically answered because this question is exactly the same as the previous one. It doesn't matter if we change the geography. Remember I talked about this reduction to the key semantic values. That's exactly what's happening here. The difference between California and Nevada isn't important. It's just a geography location right there. So it's really got reduced in some semantic value. So is the date range. So is the top 20. By the way, look at this place. Place also got to be a stop word. And as we immediately understood that, and it didn't affect our previous cached value of this question. So we got basically the same back, kind of the same type of question, same type of response back. What's really cool, by the way, is that in this system, the ability to detect, the ability not to give positive, false positive is extremely important. Because when we talk about the BI and data analytics for the business data, we don't want to guess if we're right. We can only should give you a result back if we know 100% it's correct. How about this? Let's just come up with a completely arbitrary question for web analytics that looks right, grammatically correct, but we don't have a data set for it. I don't know, something, let's look for correlation between, let's say, website sessions and, let's say, China state holidays. Yes?
Why did it happen in the
It did? Well, active basically, it didn't detect it as any kind of token, but it was not a stop word. It was an active word. It was used in analysis. We just don't show like a point of speech, tokens here. We're showing only something that's actually available to you.
I thought it was real.
No, it's actually not great. No. That will be a mistake, by the way. So let's go ahead and ask, is there a correlation between, website sessions and China state holidays some time period? Now, this question is pretty cool. By the way, I know for a fact we haven't really seen this before. So it will actually go through an entire loop right now. Now, what's really cool about this question is that it looks right, it's grammatically correct, it actually makes sense for the data, for the Google Analytics data source we have. Probably in the future we're going to be able to answer it, but I know for a fact we don't have this data. So let's go ahead and see what's going to happen here. So what happens here, you can see this icon over here. It basically shows that it's going to take a little bit longer to answer this question, maybe like 5 to 10 seconds, but we got actually a pretty good answer here, that unsupported data source. Now, what you probably haven't noticed here is that this whole question right now went through entire human review. Did anybody notice the big delay or anything else? 2 or 3 seconds. But this question right now in the backend of DataLingvo went through automatic system. It discovered that, I don't really know about state China holidays. It went through a human data analyst who looked at it right now as we spoke and pressed the button or whatever it did and actually confirmed that, yeah, we don't have it. And response got back. 3 to 5 seconds, all it took for you as a user to actually have that, to this interaction. And this is the answer is absolutely guaranteed. And that's the key value behind that. We don't guess it. We're not trying to predict anything else. If we don't know for sure, we give it to the human being. He will double check that, yes, there's no data for China state holidays. You get the answer back, which is the correct answer. It's unsupported data source. We don't have a data source for China state holidays. And you get all of this is just literally in just a few seconds. Pretty cool stuff. Now let me, yes? Well, we support, right now, the DataLingvo supports only specific data sets, like Google Analytics and Salesforce, and they work in some of the others as well. Adding this information is not trivial. It's not like, we just have to give them some data set or some spreadsheet. We have to integrate that. Typically, our belief that it will take about several months to add a new data source. So for example, if you want to add Marketo to it or HubSpot, it will take us about 2, 3, 4 months to do that. So adding the state holidays is actually just, it's not a really data source. It's more kind of reference data for us. That could be a lot easier. We can actually do it pretty quickly, like within weeks, and we probably will do it. We actually already have a technology working in the back end to add weather information, flight information, the things that are actually available. If you go to like, this Yahoo marketplace for the data sources, they have plenty there. But that's just the reference data. If you're talking about the entire data source that has its own data model, its own life, like HubSpot or anything else, or Workday, it will take longer. It's a project for us because we obviously need to have all entire processing in the back end. We have to train our data analyst. We have to have a UI for it in the back end. So it's an involved process. It's still a few months. Yes?
I mentioned business support for Salesforce custom fields.
Actually, it's coming. That's one of the reasons that, right now we don't really have a full support for Salesforce. Because unlike anything else, Salesforce has this, words of adding the custom fields, sometimes custom tables, custom views into the custom systems. So it's hard going to be support that. Probably in the first version, we will not support anything other than custom fields. But, Salesforce is fairly involved process for us, but we'll get there. We actually already have it. It's just not on production level.
But then they would have to be sure to provide a description.
Yes, for the custom fields, if you cannot mine the names of fields, they have to provide it. That's going to be the part of the sign-up process. So if you sign up with the Salesforce, we're going to ignore custom fields by default. If you want to provide them to us, you have to basically spell out exactly what they mean, because there's no way for us to digest that. Yes?
So I assume this is all, customer specific. So if someone isn't using Google Analytics, let's say they only provided you the Salesforce information and they ask anything about website session, would you give this some sort of thing back with the human analyst in the back end note, like be able to see that, oh, we don't have Google Analytics data, so therefore we're going to do that?
Yeah, so it's a good question. In this system, data analysts do not know anything specific about a customer. And that goes for privacy issues, for security issues, as well as for scalability issues. We cannot have people know about thousands of customers we're hoping to get in someday. So some of the questions may not be answered correctly. And the idea is that, we're not pretending that, when I say not correct, it's the wrong way, not optimally. We're not going to give you the wrong data set. We may not give you enough, or may give you too much. Maybe you're only asking for sessions for somehow, and we'll give you 20 other fields as well. So that's why on this interface, you have all ability to, filter this data, your ability to pivot this data, to add columns, change data range automatically and whatnot. So our expectation that people will, actually not only expectation, it's actually what we learned from kind of user discovery, is that people will use this system to get quickly from the hunch to the first data set. Actually, I had a conversation with a couple of users, a couple of potential users, and they said, Nikita, we're not going to just go back and say, what type, sort by something or pivot by something. We don't do that. We want to have initial question like this, get us back the response, and then we're going to work on this screen with whatever else we want to do. We want to pivot, sort, anything else. If we want to do something more, export to a spreadsheet, move to SAS, move to Tableau, work further. So this whole sci-fi now, vision that people will just pick up a microphone like this, say, sort by something. That's not going to work, especially in enterprise. Maybe not right now. Maybe in 20 years they will, but not right now. So most of the time people expect to type something quickly, get quick response, because that usually takes days to get something from question to an actual data set. But once you have a data set, they want to work in this interface. They don't want to go back to typing text or saying something. So what the company is trying to do right now is basically to bulk up on this interface, because the basic technology is there. We can understand the language. But we want to bulk up on this so that people can actually add columns, add data, change data, click on something, drill down, drill up, all those different things. So I'm about out of time. So if you guys have any questions, I can answer probably a couple of questions right now, or you can catch me. I'll be here throughout the whole day. Yes? Exactly. No, we're not going to support anytime soon unstructured, because then you have to basically look at your database and explain it entirely to us, which is pretty hard sales cycle. So right now we only support not only structured, but the well understood data sources. And there's plenty of them. There's plenty of business to have there. Eventually we will get into it, but it's just not that it's hard for us, it's hard for you as a customer. You can imagine you have 2,000 tables and go ahead and explain to us what the hell they mean. It's a project for a customer, and we don't expect that people will do it. But for structured data, we can do it automatically, and that's the beauty of that. You can literally, all it takes is 5 minutes to sign up once we open it up, and you're going to be able to ask questions about your website, literally by speaking to a computer. Pretty cool stuff. Yes? Right now, just one, and the company probably going to start with 1 or 2 with a gated sign-up process. It's a startup, right? So it's going to start pretty small. But the beauty of this, again, if you look back at this, approach of ACL, the whole beauty of ACL is that it has tremendous self-learning capability. So it learns extremely fast. With every question that human being touches, it probably learns up towards 10,000 different variations of the same question. It's pretty cool ratio of human touch versus learning. And the coolest thing, we don't have errors introduced. That's what really boggles many different systems, that you have to constantly sift through the erroneous or just the flat wrong answers. In our system, it doesn't really happen, because there is this human touch. And by the way, there's obviously more than one human touch. We do double checking in the back end, so we do all the right things. All right, guys, thanks a lot.